Sixth form physicists. Today we're going to talk about superposition. Superposition is when two waves meet and interfere constructively or destructively. So here I have a wave that's travelling along and for some reason it meets a fixed end. This can either be a string tied to something, it could be a slinky being held by a pupil, it could be a sound wave bouncing off a wall, or it could equally be electromagnetic waves being reflected. So visible light or microwaves reflected off a surface, or even a water wave reflecting off the wall. Now, this wave, the orange wave, is travelling to the right. When it hits a fixed point, importantly a fixed point will change the phase of the wave. So we will end up with a wave coming back to the left that will be the opposite phase. Now you have to try and imagine these two waves moving through each other. They will move in and out of phase, at some points interfering constructively, and at some points, not very good spelling there, but I'm sure you get the point, and some times interfering destructively. Okay, so the result of this is a standing wave. Now the standing wave I'm going to draw below will end up having points of constructive and destructive interference. Now, the points where there is destructive interference are called the nodes. The nodes occur at both fixed ends, okay, and this is when the waves are anti-phase. Okay, we'll come back to that in a minute. Now, the areas of maximal amplitude are where the waves are interfering constructively. These are known as antinodes. They are not anti-phase, they are perfectly in phase. So here we have 4 anti-phase points where the waves, the travelling waves that are travelling to the left and right here are interfering constructively. Now, if the waves are considered anti-phase if they are out of phase by either the wavelength divided by 2 or 180 degrees or pi radians, okay, pi radians, or the time period over 2. So one complete wave, which you can see here, is the distance between 3 nodes. Normally we express it as saying the distance between 2 nodes here is equal to the wavelength over 2. So half a wavelength. You can see this solid line represents 1 up, 1 down, a complete wave. So 3 nodes will give you 1 complete wave. So 1 complete wave is either 1 wavelength, or 360 degrees, or 2 pi radians, or the time period. But if the waves meet and destructively interfere at these points here, they are out of phase at these nodes, these stationary node points, by half a wavelength, 180 degrees, pi radians, or half of the time period. Thank you.